Sir? Sir? Sir?
Cassia, Marie, on and off. Hello?
Evening. Marie?
Hello? Sister, you can't hear me? I'm not hearing anything.
I'm not hearing anything. I see the thing on.
I have been saying good evening, but nobody's answering me. Are you hearing me?
Mommy?
I'm just hearing no.
Okay.
Sir,
Yeah, what's up?
I'm frustrated, you know.
Uh-uh.
Huh? It's not fine.
I'm frustrated.
What is frustrating you?
I still no really just say it.
What them saying now?
Saturday was mine. Big up.
Um,
Third.
Shalit said that I should have came back to her. I had a meeting at my campus at the time when she told me to come back. When I called her, she said to give her 5 minutes. Then the 5 minutes not come on now. So I can't bother.
It has to be sorted out sooner or later, yeah? So,
And I
just
still
follow through.
not seeing anything on EducaSoft. So I don't know if it's a fact that I wasn't registered. Why? But I'm not seeing any assessment. Marie came down to my campus one day since week, and I was showing her that.
So Marie, you seen the assessment? Hello?
Sir, give me a few minutes. Let me come out to that night, please.
Okay. I don't think we'll be able to have a class tonight because it's 10 past 8 now. I mean, 10 past 5. And it's just 2 hours still.
Yes, sir. So I was saying that I'm not seeing any assessments to do on EducaSoft.
All right. Let me just check something here because business chat fellows. Yeah, you were correct. You are so correct. So whenever touch base with me, then we're not seeing an editor. That's it.
Sir, I didn't get that.
I'm saying why never touch base with me when I never see you didn't see this up on editor.
Because the reason why I didn't say anything is because you said to me that
You
on
need to go to
Friday,
them. Mhm.
right. And Polly selected the courses for me and sent me back to Shalid. And I have been to and fro, to and fro, to and fro, and to and fro, and to and fro.
No, but you see, all of that update, I'm just getting now, because you see, once Polly put you on the system, that's all you need to come and tell me, because I can't put it there before the registrars and put it there. So that's why I instructed you to go back to them. So your responsibility now was to come back to me to say, sir, this is the update. And I have done that. Anyhow, you're now on Edico. So you should be able to see the stuff there now. And you need to let me know whether or not you're seeing them.
Okay. Sir,
Yes, please.
I don't understand. Last thing that you touched on last class.
That's what I wanted to. I was really hoping that would have made from 4 o'clock. From 4 o'clock, I signed in and recognized that the link that they sent to me would be activated at 5 o'clock. I sent them a message. I sent them a message at whatever time. When I recognized what was happening, I sent them a message at 12 minutes past 3 to say, no, lie. That's a different message. I sent a message from 10:33 this morning. Please remember to inform ICT that the business class first time should be amended. And I was told I thought I did at 10:49. Let me reach out to them, 10:50. And from 10:50 this morning, and when I came home and logged on, I still don't see it. I still don't see, but anyhow,
I am still in the office. I don't really work as it.
all right, so let's go. Marie, you still here? Oh, Tashana is here. No.
Hi, good
Hi,
evening, sir.
Tashana.
Good evening. Hi, people. Hello.
All right.
This meeting starts at 5:30.
Right. So can we get
Okay, so-
can we get in 15 minutes, please?
Yes, sir.
All right. All right. So I'm sharing the screen. All right. So I'm officially beginning. I know we just have 15 minutes, or well, actually a little bit more than 15 minutes, 18 minutes. It's not 12 minutes past. I have 18 minutes before the eventful meeting. All right. So let me just go through what it is that we did again on the piecewise function. As it suggests, piecewise. Piecewise means that you're going to be doing it a piece at a time. If you look at the function f of x is defined by 3 different functions: 2x minus 1, x minus 3, and x minus 1. So you have 3 different functions that are defined by f of x. Now, if you look at it, there are some conditionalities to those functions. So let us look, let us read. So f of x is going to be 2x minus 1 if x is less than 2. If x is less than 2. If x is less than 2.
Excuse me, sir. Marie says she's unable to hear.
Try earphones if you have them.
Yeah, man, try earphones because everybody else is hearing. Marie, try earphones, honey. All right, so the conditionality there is x is less than -2. Now remember, when you're looking at piecewise, less than is to the left. L for L, less, left. So less than is to the left. And of course, if less than is to the left, that means greater than is going to be to the right. So just think about it. Less than is to the left, L and the L, and the greater than is going to be to the right. All right. So the condition there is x is less than -2. That means that is going to be to the left of -2. And then in the second equation, the second function of the piecewise functions, you're going to have x minus 3. And this conditionality is x is greater than negative 2, but less than or equals to positive 2. It is greater than negative 2. Oh, so if x is greater than negative 2, that means it's going to be to the right of it. Okay, sir. So what I'm seeing now, I have a function to the left of negative 2, and I'm now seeing the functions to the right of negative 2. When we're doing a piecewise function, similar to when it is that we are working with our intuitive approach, we have to investigate what is to the left of the number and what is to the right of the number. If when we investigate to the left of the number and to the right of the number, and they both approach to the same number, we will say that the function is of a good behavior and that the limit exists, right? Once the limit exists, it's going to be continuous, all right? If it is not of a good behavior and the values differ, we say that it does not exist and the function is discontinuous, all right? So we know what is to the left and the right of negative 2. Let us see if we can decipher now what is to the left and right of positive 2. The second conditionality for the middle function is x is less than or equals to 2. Sir, less than is to the left. So we know what function is to the left of 2. It's going to be x minus 3. And of course, when you look at the other one now, we know what function is going to be to the right of 2. It's x minus 1. So you know, so the middle function is going to be used twice. Sir, how so? Look at the conditionality. The conditionality told you that it's a combined inequality. One where you have x is greater than negative 2, x is less than or equals to positive 2. So that inequality is going to be used twice. So that's how it is that we know which of the inequalities to use. Go back to what it is that I would have shown you. Less than is to the left, greater than is to the right. Less than is to the left, greater than is to the right. All right, so are there any questions regarding that? I know it's just altogether 4 of us.
No, sir, it's clear so far.
All right, McHugh.
Yes, sir. Following.
Following, and I hope Marie is at least listening or seeing what is happening on the screen, even though I sent you a copy of this. All right. Now, so the question says, determine if f of x is continuous at x equals negative 2 and x equals positive 2. And they give us the function. So we now need to find out, is the function continuous at negative 2? Is the function continuous at positive 2? That's our investigation. All right? Let us go. So we're going to investigate x is equal to negative 2. So we need to look to the left of negative 2 and we need to look to the right of negative 2. So we need to calculate the limits of 2 functions. One of the functions is going to be to the left and the other function is going to be to the right. So look at the top function. It says the limit as x tends to negative 2 and a superscript minus sign. What that superscript minus sign is saying, sir? The superscript minus sign is telling me that it's to the left. That is the function to the left that I'm dealing with. If you look at the second of 2, you see limit, and under the limit, you see x tends to negative 2, superscript plus. So the plus is going to represent to the right.
Right side.
And the negative is going to represent to the
left. So that is what I was confused about, sir. When I look at it, it says limit, and then you see x, you see the approach is negative, and it's a negative sign, and that's a positive sign. I was always wondering what that was. I know that okay, it clicks.
Yeah,
thank you.
Good. So the plus sign, the superscript plus sign, is telling me that it is to the right, and the superscript negative sign is telling me that it is to the left. That's all that it is saying to me. All right. So now, recognizing this, having written that to the right and to the left, I now need to deal with the kind of function that deals with negative 2 to the left. When I look at my piecewise function, the bottom function don't deal with it because the bottom function said greater than, so the bottom function deals it to the right. And then when I look in at the middle function don't deal with nothing to the left of negative 2. And besides, the bottom function deals with positive 2 and not negative 2. So if I'm looking at it, I will have to look at the top function and the middle function. The middle function says x is greater than negative 2. Greater than is to the right. I don't want that. I want the function to the left. So it has to be 2x minus 1. So that's why I have 2x minus 1 there to signify that's the function to the left. And when I look at the function now, the function to the right is going to be x minus 3. How you know that, sir? X minus 3
Because
Uh,
on the right, you'd find x minus 3, where it says x is less than or
Greater-
equal to 2, it is greater than or is greater than negative 2, so it would be to the
Very
right.
good. Very good. So it's greater than negative 2, so it's going to be to the right. So you have to be able to identify your functions, and then the substitution is not a problem. Just you first must identify the correct functions. Once it is that you have identified the correct functions, you are good to go. There's nothing more to that. You know why? No, it is that. So if you look at it, you're looking at the intuitive approach as well as the algebraic
Algebraic.
approach. Right, because we look at the intuitive by looking at to the left and to the right. Now we're going to apply the algebraic, because what we're going to be doing now is a substitute. So we're talking about negative 2, so it's going to be 2 times negative 2, which is negative 4.
Minus
Negative 4
1.
minus 1 is negative 5.
Mhm.
And in the other case now, the algebraic approach, we're substituting 2, negative 2. So it's going to be negative 2 minus 3 is going to be negative 5. So the mere fact that those two from the left and the right are equal, it suggests that the limits are
It's
of a good behavior
continuous.
and it is continuous, right?
Mm.
So we're going to say since the limit as x tends to negative 2 to the left and as x tends to negative 2 to the right are equal, then the function is continuous at x equals 2. That's all that there is to it. There's nothing more to it. Trust me. And similarly,
But sir,
Yeah.
sir, even though that's they're just asking about the continuous, whether it's continuous or not, they still expect us to do the workout and show where both of them will come up with the same answer. If you want full marks, okay.
and that's how you will know whether or not it's continuous. You have to show them that you test to see if the functions are continuous. You can't just look at the function and say, yeah, this is continuous and this is discontinuous. Yeah. So you
Not
have to
possible
actually
unless
work
them
with it.
cheating.
Absolutely,
Mhm.
absolutely. So let's go with the other one now. X equals 2. Let us go back to the piecewise function. Remember, everything is going to be based on the piecewise. So you're looking back at the piecewise function. And remember, when you're doing the piecewise function, you're looking to the left and the right of the function. So you need to look to the left of 2, and you need to look to the right of 2. So you're going to go back now into the piecewise to see which of the functions deal to the left of 2. The function that deals to the left of 2 is going to be x minus 3. Sir, how you know that? Because the second part of the inequality says x is less than or equal to 2. Less than, or even less than or equal to 2, is to the left. Greater than, or greater than or equals to, means to the right. All right? So to the left of the function is going to be x minus 3, and of course to the right is going to be x minus 1. So that's why we have the x minus 3 here and the x minus 1. So that is like the intuitive approach. Then now we're going to apply the algebraic method to it. So what we'll do is to say, anywhere in the function I see x equal 2. So 2 minus 3 is going to be minus 1. And 2 minus 1 is going to be equal to positive 1. But minus 1 and positive 1 are not the same numbers. Sir, 1 and 1 equals the same. No, 1 is negative and 1 is positive. It makes it 2 different numbers. So since the limit to the left of 2 and to the right of 2 are different, then f of x is discontinuous at x equals 2. F of x is discontinuous at x equals 2. It means that there is going to be a break in the graph at x equals positive 2. There is no function on earth that can give you a real and defined answer when x is equal to 2. When x equals 2, it can't work. There's a break in the graph, serious break in the graph. But at
So
x
if-
equals negative 2,
So if both
you
of
will
them
have a
were,
continuous function.
if both of them were negative 2, when we work it out and both of them came to negative 2, it would be continuous. But because one is negative 2 and the other is 2, it becomes discontinuous.
Very good.
Okay.
Yeah, negative 1 actually. So they will both have to be the same value for us to affix the continuity to it. If it is otherwise, we say that it is discontinuous. Otherwise, we say that the function is discontinuous. Right? So in order for the function to be continuous, the left-hand side and the right-hand side limits must be the same. The left-hand side limit and the right-hand side limit must be the same for continuity to take place. All right, we have like 6 minutes before the start of the meeting. I would have done this question for you and send off. There is another question. Can we try this one? Because just try this one. This one is easier because it's just 2 things. It's just
But
2
it's asking
functions.
us to sketch the graph. We need to sketch
Don't
the
worry
graph.
about that. Don't worry about that part. Because I don't do the sketch graph with you yet. I was hoping to have done that today.
Yeah. All right, so this question, all right.
Yeah, so try that one for me, please. Matthew, Dobson, Dixon, come. Man, them work up my class tonight because of my meeting.
All right, sir.
Mhm.
Sir.
I'm hearing you. Go ahead.
Okay, so it wants to know if we were to determine if r of x is continuous at x when x is equal to 3, given that r of x is equal to, and the functions are 2x minus 9 if x is less than 3, or
Mhm.
x minus 3 if x is greater than or equal to 3. So since it said equal to 3, I work with the bottom one, and I got 0 as the answer because x is 3, and 3 minus 3 is 0.
Mhm.
And when I work out the top one, it is 2. When you put x is 2x, you times that 2, 3 is 6. 6 minus 9 is negative 3. So it is discontinuous because on the, let me say that x is less than 3 on, I think that's to the left,
Mhm.
it's negative 3, and to the right, it's 0.
Okay, very good.
Okay, so I got it, sir.
Mhm. Sounds right to me.
All right. It was right there. All of this a pen and paper in front of me. So,
Yeah, so
Alright.
it is discontinuous at x equals 3.
mhm.
All right. So Marie left. Matthew, I hope these explanation would have cleared up a little bit or two of what it is that is happening. I'm going to turn you over now to the meeting. I'm going to ask you to go ahead and join the meeting now. All right?
Will do, sir. Thank you.
Bless up.